Hello everyone, my name is Alina Bonadonna and I'm happy to welcome you all in our another special launch webinar from NEMIS Technologies. And let's welcome our product manager, Julian Isen. How are you,
Hello.
Julian?
I'm fine. I'm happy to be here and being able to present our new product.
So am I actually. So guys, as always, the same question what I asked you during the previous Academy session, just let me know if you hear us well, see us well, shoot on some reactions. And as always, I start first. The reaction button you can find on the bottom left corner. Yeah, I see some reactions coming, so probably our streaming is running smoothly. So yeah, just a bit of short background. Today, we are super happy to present you our new swabbing tool, MaxiSampler. Yeah, I'm prepared. And Julian, as always, will share more scientific data behind it and in general showcase how to use it. And basically, you have perfect opportunity today to ask everything you're curious about. So, Julian, are you ready to start?
Yes, except that you have to make me the moderator that I can share.
Yeah, definitely. My apologize. So, okay, let's try again.
Now I can share, yeah.
Perfect.
Um,
So, for some time,
um,
I will disappear, and time is yours, Julian.
wait. Um, why isn't it? Hmm?
Okay. And me, I always, guys, encourage you to shoot on questions during the session as well. Be active and don't hesitate to shoot on even the trickiest question because that's why we gathered today to share our knowledge and
Yeah.
uh, yeah, fulfill your
Sorry, Alina, can you maybe share it because I cannot find this window. I don't know what's happening.
yeah, yeah, yeah. No worries. Sometimes it happened, so that's why actually I'm here.
Okay, that's nice. So I just tell you when to go on to the next slide.
Definitely, no worries at all. Just let me know if you see my screen.
Yes, I see. Yeah. Okay. So welcome again to today's webinar. And I'm talking about our new device for large surfaces called MaxiSampler. Next slide, please. So, as you probably all know, sampling really is a crucial part of environmental monitoring. Um, and if you can envisage the whole process in environmental monitoring, so you have the sampling in the production rooms according to the sampling plan, then you have the sample transfer. Here it's also really important the time frame and the temperature during this sample, and then finally the sample is analyzed either directly on site with a test like ours or at an external laboratory where it is shipped to, and then certainly follows the data analysis, and based on this analysis this decision on corrective actions if needed, and then also planning for a follow-up sampling, maybe a modified sampling plan, and then coming back to the sampling itself. Next slide, please. So why why is this sampling so important? So microorganisms on surfaces, this is really an extremely and incredibly complex topic. So you have the strengths of adhesion, uh, how strongly these cells really attach to the surface. This is influenced by properties of the surface, especially the material, but also the morphology and the cells themselves. And they can have different polysaccharide compositions and different proteins sticking out from their cell walls, like fimbriae. And all of this will influence all of this, how strong they attach. And the drying, it's also very important, because everybody knows if you spill milk on a surface, it will form a very rigid film. If you leave it overnight, the drop, it's really hard to remove. And that all of that applies also to factories. And you can imagine if there's some cells entrapped within such milk, for example, they will also stick very strongly to the surface if it's drying. And then the other thing complicating everything is that the cells can be then enter like a resting state, especially if they are dried, but also if it's cool. And then it's also really hard to recover them and grow them. And then further complicating everything is that any additional matrix, like food residues, will affect, on the one hand, the survival rate, and then also the strength of adhesion. And then even more problematic is that microorganisms can form on their own, like kind of a sticky matrix for allowing them high persistence and protections. And that's what we then call biofilm. You see here an image. It's really hard to study the bacteria on surface on site. It's really cumbersome, but these guys in this paper managed it. They did kind of a negative imprint with some kind of film which solidifies on the surface, and then did a gold coating, and then finally were able to do an electron micrograph. And then with this false color image, you see how it looks like bacteria on the surface. You see very small crevices in the micrometer size. It's bacteria sitting in there, very scattered. So there might be on one place some like 10, 20, 100 bacterial cells, and then 1 centimeter on the side, there's nothing. So it's also very variable. Next slide, please. So why then is the choice of the sampling device and of the moisturizing solution important? So on the one hand, the sampling device determines how much force you can apply to a surface. As I said, it's sometimes really hard to remove attached cells. Then, but on the other hand, it's really important that you are able to reach hard to reach places like edges, grooves, valves, tubes, crevices, holes, and so on, because especially in such places, you can have bacteria sitting there. Then another thing to consider is how much area you want to cover, and certainly how big your sampling device determines that. And then also how the device is designed can influence the effectiveness and capacity for cell pickup. And then another thing to consider is how well it is designed for avoiding cross-contamination during sampling by touching it. Even with gloves, you can have cross-contamination if you don't watch out. And then also the question is, once you have sampled and put it back in some container or so, how well do this bacteria survive on its surface? And does it allow maybe even some initial replication? And then the final thing, which is also important about the sampling device, how well does it finally release live bacteria into a resuspension buffer if you do it later on, like plating, and also enrichment. Next slide, please. So then not only the sampling device, but also the procedure is quite important. On the one hand, it's important how is your device, is it wetted? So with a moistening solution, is it even a solution which can neutralize disinfectant, so-called neutralizers? Does it contain nutrients to like give an initial boost to the cells? or do you want to avoid that and go in with a clean dry swab because it's already anyway wet? So all of that has to be considered. And then it's really, really important for environmental monitoring that the sampling spots and the areas are really precisely defined. And then that you come back to the same spots repeatedly, because only in this way you will be able to have a trend analysis. So then also usually also in ISO norms, it's usually advised that you go multiple times over the same spot in the same area in different directions, at least in two directions, but we advise to go like diagonal, vertical, and horizontal. And then while you're doing that, it's always good to turn the device so that you use all area of the device for pickup of cells. And also it's important that you apply sufficient pressure, as I said, because cells can stick very strongly to surfaces. But still, you certainly shouldn't break the device. So that's also to have the right compromise between pressure and not breaking. Next slide, please. So what are the sampling devices which are available today from commercial suppliers? So on the one hand, certainly everybody knows the swabs. Swabs can come in all forms and colors and so on. Important difference is that you can have like standard cotton swabs, but very often they are more like flocked nylon or nylon fibers, and all of this can influence the efficiency of these devices. Then you have sponge sticks. It's like a hybrid of a swab and a sponge. And these are intended to cover larger surfaces. And either it can be that the swab or sponge at the end is released or not. So you have all kinds of different varieties of these. You can have them pre-moistened or not pre-moistened with a certain buffer or medium. And then a classical thing is also to use sponges or even wipes, which you can buy sterilized, also sometimes wetted or not wetted. And these are just directly used with gloves and then placed into bags, which are then sent in for further analysis. Next slide, please. So how do such different sampling devices perform? I hope you can read it. It's maybe a bit small print. That's from a scientific paper. Unfortunately, there's not like extreme amount of data available on such really one-to-one comparisons, because it's really a quite cumbersome work to do that. And also you have very high variability of the methods, because in the end, the only way to do it in a reasonable way is to do plating. And you probably all know that in plating, you have a lot of factors giving variability. So you can see here the top is a sponge, and then compared to pre-moistened tissue, or you already have a big difference, the sponge being more effective, and then the cotton swab. But what you can also see here, it really also depends even on the strain, even of the same species, you can have variation. And you see in the plus minus number there at the end, how high the variability really is. That's really 30, 50% or so. What they found out that in the end, sponges are quite good, but also swabs are not that bad. And then they investigated kind of a new idea to have, they just used rollers for paint from the normally used for painting, and with different materials. And they, in their study, they were quite good, although there was also really differences between the two strains. And then they compared it also to direct contact plates Aloha, which were also not that bad. and the petrofilms. But in the end, petrofilms you also do swabbing and then resuspension, and then go to these petrofilms. And you see here there can be quite some difference, but the main message I want to tell you, the main message is that there's always quite high variability because the intrinsic complexity of cells on surfaces. So the best way is also to do a statistically relevant number of samples and not just do one sample. And have really quite a lot of different places where you sample to have statistically sound data. Next slide, please. So we now, because we got often requests, can we also use sponges with your tests? And then we say, kind of difficult, because how do you fit a sponge into such a small tube? We thought of different things like squeezing it in a bag and then putting the suspension into our test and so on, but none of that was really useful. And finally, we came up with idea for a large sampling device which will really fit into our tubes. And that's you have a handle there with a really robust handle which is firmly attached, and that means that you can really apply also quite some force to surfaces, and that this handle is removable by a simple click mechanism. This device also then contains a kind of a giant swab barrel, or however you would like to call it. It's a solid, plastic solid round thing, and it's coated, the half diameter is coated with a flocked fiber coating. And that's really the similar coating that we use also for our NEMIS standard swabs. That's on the outside, and it's the device is hollow inside, that our NEMIS tablets can go through when you do our tests. And I think, as far as we know, really the first ones who could offer a large surface sampling device which is compatible with rapid on-site tube tests. And that's why we also filed a patent on it. Yeah, and it's really simple to use. I go through, in the next slide, I go through our eye view. You have to know that always in the packages, when we ship this product, there is also the eye view in the package, but you can also always load it down from our homepage. So next slide, please. So this is now from our eye view, also always with images. So we ship our product in a quantity of 20, and then in a box, and then there will be some reservoirs, sterile reservoirs, which are used then for moistening of our device. And we have different options as a moistening agent, so that these are also then different articles, different products, either PBS or N-Light neutralizer for neutralizing disinfectants, or BPV. And depending on the test, you can use two different ones for our different tests. We have validated that. So you just pour this buffer into the reservoir, then dip in the MaxiSampler barrel side until it's wetted, and then shake off excess liquid, and then best put it back into the pouch. So the pouch is sterile, and it's shipped sterile in a closed pouch. Put it back in there. We also have now a clip available, a simple clip from an innovative Swiss startup, where you can close again the pouch. You go with that pre-wetted pouch to your sampling site, and then do the swabbing. And the swabbing, as I said, best do it in different direction and do it while also turning the swab to both, incline it to both sides, so you can take advantage of the whole surface area of the swab and for taking up cells. So I forgot to say that the length of this swab barrel is about 8 to 9 centimeter, and it has a little tip, and with this tip you can also go into holes, so it has also some small swab functionality. We always do our testing of this product on 11 times 11 square stainless steel plates, but we are quite sure that areas up to 0.3 square meters, but even 1 square meters probably can be swapped quite easily. But for this, we will also then need more field data. Next slide, please. So then once you have sampled your surface, your area, you can put it back into the pouch and go to the place where you do our tests. And it's then very easy to release the barrels with the sample in the tube. You just place it inside the tube and turn the handle upwards. And by this, the click mechanism will be opened and the barrel will fall down into our tube. Maybe it needs a little bit movement, but usually it should go spontaneously. Then, in the case of the El Mono and the N-Light test, we've validated that you can leave the device inside the tubes. And then it's very important, that's a crucial part, that the tube is properly, the swab part is properly rinsed. Just by having the tube in a horizontal positions and turning it up and down so that the liquid inside, the broth inside, flows from one side to the other on the bottom, and always rinses the swab surfaces. This should be done at least 10 times, and it's also very important that the fiber coating faces down, so the liquid will always flow along this fiber surface to release bacteria and let them flow down to the broth, which is 2 ml in our tests. And then everything else is just the same as if our tests are used with the standard swabs, which are broken into the tubes. And yeah, it's then always also important to close the biosafety cap to have a safe enrichment. Yeah, that's all. And so it's not much more steps than the use of the standard swabs. And yeah, it's more easy to cover a larger surface. So important is now to note that for Salmonella risk and the LSPP tests, it's important to take out the swab again after rinsing. That's we validated this, that it's really important. Therefore, the handle has a little modification at the end where you can just go into the tube and press the end of the swab, and then it can be easily removed again, shaking off any liquid, and then just discard it via the normal waste. And then everything else is then again the same as if you would use the normal swabs. Again, yeah, it's really important to do the rinsing well. Next slide, please. So to convince you that it is really working, our device, we did quite some tests in the lab with dried cells, and here we just compared how well cells and generally are recovered and released again just by plating on standard plate count agar. And here always the same cell suspension was used. The cells were diluted in sterile broth, and then kind of we call it spotted on 11 times 11 centimeter sized steel plate in 10 microliter spots, which will dry quite fast. And then we dry it at 1.5 hour at room temperature. And then the maxi samples were moistened in our N-Light neutralizer, and the scrub samplers were used as received. They're already moistened with pre-enrichment medium. So then we swapped the surface, these plates in 3 directions, and then the devices were resuspended in the same volume of BPV, buffered peptone water, and then made sure with sufficient mixing that real cells are released well, and then the suspension samples were then analyzed on plates, on plate count agar, and you see here that we achieve quite good recovery rates with our device of 10 to 30% for both gram-positive and gram-negative bacteria, and we are well in the range, or sometimes even a bit better than the 3M scrub sampler, which is a quite popular device used for environmental monitoring. Next slide, please. So now it's really also important to prove that our device works with our tests. So again, we inoculated steel plates with Listeria monocytogenes, 2 different ATCC strains, and then used decreasing levels of colony-forming units. Here you have to always bear in mind that only like 10% of the inoculated cells will survive or recover. So and we see here that really we could go down to really quite low levels and still get positive test results with our L mono tests. Next slide, please. That is something you might ask, and that's why I already put that slide in, is how does the MaxiSampler compare to our standard swaps with breaking point? Well, they perform quite well, but for small sampling areas, the standard swaps perform a little bit better. So we advise not to switch fully to MaxiSamples, but really use MaxiSamples for big surfaces which are also not extremely dirty. So that's our advice. And the swaps will still be very important, especially to go to niches and edges and ridges and so on. Next slide, please. So here is how the MaxiSampler performs with the Escherichia coli tests. With Escherichia coli tests for positives, we always get very high relative light units results. You see here we compared both of our available wetting solutions for the E. coli tests, and they were both performing well, so always positive results with a very low number of inoculated bacteria. That's here I show you why we say you can leave the MaxiSampler in. Although you will get a little bit lower signal, it's still clearly very strongly above the threshold, which is 10,000 RLU. And yeah, the negative control, as expected, has sterile broth on steel has very low values. Next slide, please. Also, we validated the test, the MaxiSampler for N-Light L mono tests, our N-Light L mono tests. Also here, we found then that it's important to remove the MaxiSampler after rinsing it in the tubes. You see here with also quite low inoculation levels already. We get 3 of 3 positives, and you see here the RLU values you achieve, which are quite high in this case, and the sterile, as expected, are always negative. Next slide, please. The same is true for our really novel Listeria SPP test. Here you have to bear in mind that the threshold will be lower than for the other tests, but also the signals will be a bit lower, but still there's a clear distinction between sterile negative tests and positive tests, also with low inoculation levels of Listeria monocytogenes and Listeria innocua. So all in all, we tested the device rigorously with our tests and found that they are really suitable and that you can use them for sampling large areas and do a environmental monitoring with them. Next slide, please. So we already try out them in small field trials in ready-to-eat factories, and there with our salmonella risk test, we've found that it worked. So we got a certain level of positive results, which is in the same range for such type of factories as with the swabs. And also you can do follow-up analysis. And here there was no salmonella confirmed, but you have to bear in mind that's the salmonella risk test. So it's expected that there will be maybe only 1 in 20 or so real salmonella. The others are these closely related organisms which have similar physiology as salmonella, so the Citrobacter, Klebsiella, and Enterobacter. The same with the El Mono test. There was like 2 positives in this one study. In this case, there was not they were not confirmed, but that can also sometimes happen. But still, it shows that in principle the test works. So anyway, all the negatives there were negative, and also in the case of salmonella. Next slide, please. So let me go through all the points again as a summary. So first of all, sampling really determines in a large part the quality of environmental monitoring data. So you should really have an eye on it, how you do it, what you use for it, where you do it. Then the microorganisms in generally, that's also why sampling is so important. They can be really firmly attached to surfaces and hard to pick up, is particularly in biofilms. And also our opinion is that there is no one size fits all sampling device. So in some situations, a large sampling device might be better, in other a small sampling device. And all of these devices can have distinct advantages and disadvantages. The surface contact material of sampling device can also matter, but in our opinion, really here is more really more well-defined research with good controls is needed, because it's really a complex topic. Then we think we have now brought to the market a quite useful new device, which we call the N-Light MaxiSampler. And I think we showed that it allows efficient sampling of large surfaces of injured and dried cells. We showed also that the MaxiSampler is in fact compatible with all our N-Light pathogen or indicator tests. A note of caution I want to drop here still is that you should avoid overloading the MaxiSamples with a whole lot of food matrix and dirt, because that may negatively impact our tests. It's just then better to go to visually clean surfaces. That's, I think, the most useful environment where you can use the MaxiSamplers for. On the other hand, I mean, feel free to use the MaxiSamplers to also sample very dirty surfaces and then send it into a lab. I mean, that's always possible, but then it should be like enriched in a larger volume of enrichment broth. So that's all from my side. Next slide, please. Or finish the sharing. Yeah. So I'm very curious about any questions you have, and you can come back to me anytime also via tech support at NEMIS, and we'll try to answer any questions about the MaxiSamplers.
Thank you so much, Julian. And what I love really in our webinars that people don't hesitate to ask questions, and we already have some questions.
Okay, that's good. Yeah, very good.
So the first one is coming from Esther. Why the difference between the methods about incubate with or without the MaxiSampler? Probably, what are the difference, right? If I understood correctly, like, or what are the main difference basically between the methods about incubate? I mean, probably it's about why do we sample with MaxiSampler inside versus.
So this why I think probably it's meant that why in one case you remove the MaxiSampler after rinsing and why not. It was just the case that we found that out during our development of the device, and we would have liked it that it stays in, but we saw that this bigger device has an impact on our reaction and luminescence reaction, and it's way better to take it out again. And for the El Mono and the E. coli test, we saw that it's okay to leave it in, but for the other two, we just see the performance is much better if you remove it after rinsing. That's just the case, and the reason it could be that some of the reagents stick to the material. That's our most reasonable explanation for now, and maybe in some future product versions this problem will be solved.
Yeah, and using the opportunity to showcase how it works. Okay, Julian, if you don't mind, let's comment
Yeah,
how we do
yeah.
it.
I
So,
interrupt if it's wrong. Yeah, yeah.
is it correct, right?
Everything
Yeah,
correct, and not just that's all, and then close it.
but don't close fully, right?
In
Because
the
it's
case
so.
of salmonella, not close fully. Yeah, and then check
Mm-hmm.
that the coating is to the bottom,
Mm-hmm.
so that the no. Turn it in the horizontal position, horizontal, and then check that the ridge is open. Yeah, and then
Yes.
just go like yeah.
Is it correct?
Um, yeah, just check that the lower part is to the bottom. Yeah, like this, and then just go. You don't have to turn it completely, but just go up and down like this, and then you see
Okay. Like this.
the liquid
Yeah.
flowing along the device. Yeah,
How long should
like
I
this.
do like this?
10 times like this,
Mm-hmm. Okay. More or
and
less we
then
did it.
in case of the salmonella, you open it again, and now with the other side, go in, remove it, shake off the
The,
liquid.
the question would be, what should I do with it after? Should I put it
That
back
can
in?
be go in the bag, and then because it's not yet enriched, you can place it to the normal waste bin,
Okay.
like any other sampling device you would use. So
And then
then,
I close it as always, right?
yeah, yeah. Yeah, and
Here, how
then
we hit.
everything is the same then, like for the other test that you incubate and then release the tablet in the cap read.
Okay, and what's about, for example, if it's a E. coli test, like Listeria monocytogenes, so should we leave it like this, right?
It's all the same, and then you just can leave the swab in, and
Mm-hmm.
everything else is the same. So the release into the rinsing, the release, and so on, and then just put it in the device. Yeah.
Okay, I just wanted to pay your attention, guys, on the attached documents here. On the upper right corner, you will find the Maxi sample IFU, which Julian already presented a bit during presentation, so you can check it out, download it, and in case you want to get a presentation, just drop a message to me, and I will share it as well.
Yeah.
So, and also I want to show you this magic closure for our Maxi sampler, and it will. Julian actually mentioned it, so it's very easy to keep it like this, so nothing will be like dropped outside.
Below. Yeah. Mhm.
And Julian, I have a question. Why didn't you mention that we can use Maxi sampler with ATP test?
There, unfortunately, it's not compatible yet, but maybe in a later product version. It's just that during our development in the current form, it's not working. But there might be a future version which is. We have to put some more effort in it. Anyway, we are constantly trying to improve our products, and we are very happy for any feedback from you guys, from distributors, and from the um, users in the food factories about things you think would be nice or which would be good to improve on our tests. And also, we are all very open to collaborate, like in pilot trials and field studies, and discuss how to do them and how to sample, where to sample, and so on. So yeah, just contact us, and we're happy to help.
Yeah, and probably question which can come from our listeners and customers, is it already commercially available? So can we ship the first orders?
Yes, yes, it's on stock. You can order it. You can order it with these three types of moisturizing solutions. Maybe in future there will be pre-moistened versions, but there we have to see how people, if people really want to have it, or if it's maybe even better to have more flexibility. Yeah, as said, you can also use it dry if you want. We will probably go for AOAC certification also of this device with our test in future. And yeah, I'm happy for any feedback and comments on this new product.
And also a question regarding motion solution, because you mentioned neutralizer, and also we have a different motion solution for listeria test. Is there any specifically recommended for Maxi sampler, or it can be
Yeah, so
used
we
any?
generally we recommend the neutralizer because this has generally the best recovery, but there might be some factories or circumstances where they would like to rather have a simple PBS buffer or so. But in general, the neutralizer works good and has this effect of like also boosting cells with nutrients and being gentle to the cells. So that's what we recommend.
Great. And there is another question coming from Rainer. Why are you keeping all three media? Probably it's about moisture solution, since the neutralizer can be used for all pathogens. I think the best for customer and distributor to keep just one on stock.
Yeah, that's something we also have thought about. We just started with the PBS initially for the El Mono, and it might be, but it could also be that some customers still would like to have these different options. But for Salmonella and E. coli, we actually might drop the BPV. It's just that BPV is like the standard resuspension solution used for E. coli and Salmonella. So yeah, but for you distributors, I would advise you just to usually recommend neutralizer, except there's some objections to it.
Okay, great. If there are not no other questions coming from our attendees, I would love to. Ah, no. Ah, yes. So there are just comments to you, Julian, with the highly appreciated time you spent on giving us this presentation.
Oh, then
And it's just,
you're really welcome. It's fun for me to share
let's show some
our
reactions to
data from the
Julian.
lab. So it's good. People interested in this. Yeah.
Yeah, guys,
Okay.
and our webinar is recorded and as always will be published to our LinkedIn and plus sent out to you privately, if I'm not mistaken, in tomorrow's follow-up message. But to get presentation, drop me message in private email and I will get back to you with a presentation. So, and of course, I cannot skip mentioning NEMIS Academy because already this Friday we have another great webinar. So keep subscribe to our NEMIS Academy. And thank you, Julian, for
Yeah.
time
Thank you.
and for
Thank you for
knowledge.
the preparation. The nice and yeah. Hope
Have a
to all
nice
see you
day,
in
everyone.
webinars. Yeah. Okay. Thank you. Bye
Thank
bye.
you. Bye.